Today on How It's Made Dream Cars, a supercar that's inspired by multiple Le Mans winning race cars, the Audi R8. Audi's quintessential two-seater is the four-wheel drive R8 Coupe, built in Germany. The heart of the company known as Audi began in 1899, when engineer August Horch introduced his first car brand, Horch. At the time, the main competitors were Mercedes and Benz. In 1909, after disputes with his business partners, Horch left the company he founded to start Audi. A year later, the first models of new cars under the Audi name were produced and immediately attracted people's attention. But in the 1920s, car sales were down in Germany, and strong competition from abroad forced the German car industry into financial crisis. In 1932, in order to survive the crisis, Audi grew by merging with car makers Horch, DKW and Wanderer to form Auto Union. This union was the inspiration behind the symbolic overlapping four rings, now known as the iconic Audi logo. The R8 uses a lightweight aluminium chassis and body. Fitted with a V10 engine, it accelerates from 0 to 100 kilometers an hour in 3.9 seconds. Up to 2013, Audi have won 12 out of the last 14 Le Mans 24-hour races, and it's that race history that's behind the R8. The core of this car is based on a space frame chassis and monocoque design. Interlocking struts form the chassis pattern with few interior supports, while the chassis, engine and suspension are integrated into the body. Weighing 210 kilograms, the space frame is comprised of 22% aluminium plating, 70% of extruded aluminium profiles, and 8% of an aluminium-based vacuum pressure casting. Built in the newly renovated factory at the manufacturer's aluminium site, the space frame chassis is assembled by first placing the structural struts into high-pressure vices called clamping fixtures. These jigs lock the chassis pieces into place, ready for the next stage. The frame parts are welded together using torches that heat up to 900 degrees Celsius. Aluminium burns more rapidly than steel, so the work has to be done quickly. Once the welding is complete, the frame section is moved using a hoist to the next workstation. The car's chassis consists of three major sections: the central floor, the rear end, and the front end. An overhead conveyor delivers the chassis sections to another workstation where the large underbody parts are lowered to be welded. The frame pieces are positioned in the clamping fixtures. These hold the chassis parts into their finished positions, creating the ultra-lightweight aluminium undercarriage. Then every join on the chassis is meticulously welded. Once the welded joints cool, the chassis is released. An overhead transfer belt then lifts the frame to another workstation. One of the very few robotic operations in the body shop is the insertion of flow drill screws into the car's floor and cabin substructure walls. A fastening robot spins the self-tapping screws at high speed, where they flash melt into the aluminium. This creates an elongated threaded shank on the back of the aluminium sheet, which adds to the pull strength. Self-tapping screws drill their own holes when they're screwed into materials like wood, plastic or metal. The floor is reinforced by custom lightweight tailored aluminium blanks. The thickness of the panels varies based on their design and function. It takes 308 automatically placed self-tapping screws to join the components of this car's substructure. As cars are produced to meet the customer's specific requests, the vehicles are produced in sequence. 1 week before the body shop begins assembling the chassis, sister factories and suppliers from across Europe begin their production of individualized items, such as seats, running gear and bumpers, to meet each car's specification. As the chassis stands at a workstation, parts such as the doors are fitted. The doors are bolted to the chassis using torque wrenches. Next is the installation of the body's boot lid. Since the car's engine is located in the midsection, the cargo area is in the front. While attaching the boot lid, the mobility of its gas pressure springs are also inspected and certified to ensure the lid is a perfect fit and moves properly. Before the body panels meet the paint shop, any excess residue is removed using grinders, files and high-powered sanders to create perfectly uniform surfaces. The aluminium panels are then finely sanded by hand to prepare the finished surface for painting. For this car, the total production time in the paint shop is 4 days. 11 optional colours are available. After 96 hours of construction and a 5-stage paint process, the body is now ready to receive its running gear and V10 engine. The braking system on the Audi R8 is directly modelled on its racing version, allowing it to stop harder, faster and in shorter distances, whether on the road or track. First, a disc is set on a work table. Then the steering knuckle is added and locked into position. The knuckle will be attached to the suspension components. A smaller caliper, which is for the handbrake system, is positioned. Then bolting pins fitted and fastened using an automated wrench. Next is the installation of the hydraulic brake hose. Installation of the lower and upper suspension control arms, more commonly known as wishbones, is next. Using an impact driver, the narrow end of each wishbone is bolted to the steering knuckle. The control arms pivot on ball joints and help dampen the vehicle from road shocks. They also control the motion of the wheel throughout travel, controlling parameters such as the camber angle, toe pattern, roll center height, and more. A tie rod is then put into position. This is a structural unit that attaches on both ends of the steering rack, which aids in the pushing and pulling movement of the wheels. Added next are the monoblock aluminium brake caliper and its pins, which houses the brake pads and 6 pistons. Finally, a few more parts are fitted to the tie rods, including the bolt and socket arrangement with a tapered stud for the mount bracket. This will complete the assembly, so it's ready to join the rest of the running gear and the new chassis. Once the brake assembly is finished, a hoist takes it to another workstation. Coming from a sister plant in Hungary, this 257-kilogram 10-cylinder engine is moved to a workstation where it receives additional parts. This 5.2-litre engine generates 525 horsepower, giving the car a top speed of 317 kilometers per hour. During the addition of the further parts, the drive plate and its screws are added to the engine flywheel, a device used to store rotational energy. Each screw is fitted by hand, then tightened with a power drill. Before connecting the engine to the transmission shaft, the drive plate is scanned into a computer for the car's assembly records. Using other computer software, the screws are checked and verified that they're fitted correctly to the drive plate and with the right amount of torque. Once it's verified that the drive plate has been installed correctly, the double clutch transmission is fitted to the V10 engine. The two large running parts are joined together. Now it's ready to be installed into the R8 to become its beating heart. Today on How It's Made Dream Cars is Audi's R8 Coupe. It's made from more than 5,000 parts over a period of 8 days and along 14 stations in the assembly hall, each with a strict cycle time of just 30 minutes. The rear of this sports car is the most complex part of the vehicle. The chassis sits on a transfer dolly, which is manoeuvred into position to drop in the V10 mid-engine, the gearbox, the fuel tank, interior panels and other trim items. Cabling and piping are also fitted. Because this car uses a flat oil pan, it allows the engine to be installed lower, moving the car's centre of gravity closer to the ground, resulting in better road handling. Next, the chassis along with the new engine and interior components is rotated to add more electrical wiring and piping to the running gear. As further parts are fitted, they're screwed in place manually. During this process, 50 to 60 parts will be installed within 30 minutes. Using a specialized lifting device, the braking assembly unit fitted with carbon fiber reinforced ceramic brake discs is installed. The locking bolts are tightened, securing the unit into position. Next, the body and chassis are shuttled by a transfer hoist down the assembly line to station number 9, where key aesthetics and functional features will be added. The car's retractable roof is lowered into place. The folding roof is made of cloth, which has less weight than a hardtop and further reduces the car's centre of gravity. Once fitted into position, the crane releases the component. At the same time as the bolts of the convertible roof cover are fastened, the car's LED rear lights are also attached. LEDs have a very long service life and illuminate 250 milliseconds faster than conventional bulbs. Also fitted at this point are the battery, dashboard and the front and rear bumpers. The rear bumper also conceals ultrasonic sensors that assist the visual and acoustic parking system. Finally, the engine cover is installed, which is set between the fully automatic roof cover and the retractable rear spoiler. Using a torque wrench, the cover is connected to the hinges before its gas pressure springs are attached. In another work area, a robot adds high-strength adhesive to the edges of the windscreen. It's carried to the car using suction cups and lowered into position. Afterwards, the bottom cowl and body shell brackets will be installed to further contain the glass. Also fitted at this stage are the steering wheel and the steering column airbag, along with its electrical wiring. The car's interior can be made from nappa leather of lamb or sheepskin, as well as Alcantara, which resembles suede. In the car's convertible version, a special pigmentation prevents the seats from overheating in the sun. The leather bucket seats are fitted inside the cockpit using a seat installation lifter. The pneumatic arm makes it easier to insert any electrical wiring in and around the seating. With the aid of a lifting device, a 19-inch aluminium alloy wheel and tyre is placed onto the front wheel plate and bolted into position. At another workstation, self-tapping screws are used to attach 6 aluminium underlining body panels underneath the car. These panels add further bodywork rigidity. They also generate more downforce at high speeds and give some protection to the running gear parts from the environment. Only 20 R8 cars are made daily, and when they've been built, it's time for a series of stringent tests. The R8's V10 engine offers power, torque and fuel efficiency due to its direct fuel injection system. This was originally developed for the Le Mans 24-hour race cars. Named after the Audi Quattro, this factory was primarily built to produce high-performance sports cars. Inside on the assembly line, on a section known as the finish line, the final construction details are inspected, where all electrical systems, lights and the power steering are checked. Also added are operational fluids, such as coolant, oil, transmission fluid and brake fluid. Next, the car is sent to endure some meticulous driving tests in and around the factory. The car now stands in a dynamometer roll booth which uses multiple drive rollers for roughly 10 minutes. The car is often driven at speeds of up to 160 kilometers an hour throughout this evaluation. Vehicles are driven while a computer conducts a series of operations simulating various driving conditions. The transmission, suspension, braking, and not to mention the engine's horsepower and torque are all examined during the test. The testing also includes load simulation, such as uphill driving. But the testing doesn't end here. Outside, the car is driven on a series of tracks as part of a pre-delivery durability test. The special surface track is a low-speed course with a variety of demanding road conditions. Test drivers check the transmission, steering, suspension and brakes, plus the overall ride and handling of the drive. The Performance Development Test Track evaluates new and prototype vehicles in a high-speed bowl with lane-changing areas, straights and bank corners. The car's top speed and performance with the roof down is also evaluated. Also, every car is driven at a high stress level, and sound tests are completed to check for interior noise, noise vibration, wind noise, and running gear noise. Beyond the factory test tracks, the manufacturer has a set of hill routes and city courses that progressively challenge the vehicle's performance and durability. Following the testing, the car returns to the factory for more manual quality assurance. After a high-pressure wash, the sports car bodywork and paint is checked and verified. Next, the panels are buffed to remove any dirt, dust or liquid picked up during the test. After 8 days, 14 workstations and with more than 5,000 parts, the R8 is finally ready to leave the factory for the open road. To ensure that it's delivered as it left the factory, a protective white new car wrapping is fitted over the vehicle. An outer film layer protects the car from water, while an inner fleece layer protects the paintwork from any scratches. Even with the protective wrapping, the car can still be driven to where it needs to go next. The R8 has been built using the knowledge the company has gained from 12 victories at Le Mans since the year 2000. And that motor racing heritage also influenced the design of the car. But the car's functionality was never compromised. It can change from a convertible to a coupe while travelling at 50 kilometers per hour. From one original company to the eventual merger of four at the start of the 1930s, the Audi R8 is the culmination of over 110 years of motor manufacture and 70 years of racing experience. Its big brother has lit up the track at Le Mans. Now it too can cruise the city streets and country lanes.
A writer needs a space to turn over a new leaf on Animal Planet's next in Treehouse Masters. Here on Discovery Next, the words are flowing fast, especially between Beep and Holly in Texas Car Wars.